So in a typical office setting, you may think about the installation and the setup of a new printer, not really always cause for celebration, sometimes cause for consternation. But when your office is like Wilmore's, orbiting more than 200 miles above the ground, the scientists around the world will take notice. So today we are joined by Bill Hubscher out at the Payload Operations and Integration Center at the Marshall Space Flight Center in Huntsville, Alabama, who's going to tell us a little bit more on the installation of this first 3D printer in space. Bill?
Thanks a lot, Dan. As we go about science activities on the space station, as you mentioned, there's very little that we can call routine. There are many challenges about living and working in space, including when a part or a tool is broken or simply is not working correctly, and the spare part is 200 miles away here on the surface of the Earth. Well, explorers traveling Mars or traveling to Mars or to asteroids will face these same challenges, but they won't be able to get any supplies from a supply ship. The station, as you mentioned, is the ideal laboratory to test these technologies to help us live and work off the Earth. Well, this morning on the space station, Commander Butch Wilmore is installing a brand new device that, once installed, could change the way we handle fixing problems in space, a brand new 3D printer. Here to talk a little bit about it this morning is project manager for the 3D printing project here at Marshall, Nikki Werkheiser.
Good morning,
Nikki,
Bill.
thanks for making the time this morning.
My pleasure.
It's a busy and exciting morning for you and your team.
Absolutely.
Tell us a little bit about what Butch is doing first thing this morning.
So today is a very big day for us. This morning, first thing, what they did is they took the 3D printer out of the stowage location where it has been since the SpaceX 4 launch, and they've actually installed it into the Microgravity Science Laboratory glove box. There, it's really important. Obviously, we're getting all the electronics hooked up, making sure everything's functional, testing the commanding. Also, actually, the printer has two windows, and we're placing the MSG cameras very closely to those windows so we can monitor the actual extrusion process as the prints and the layers are being deposited. We'll be able to see that in detail. And then later on today, once all of that is set up, and we'll actually print our first calibration coupon. We'll probably print a couple of these. And this is part of the functional checkout for the printer itself, just to make sure everything is functioning correctly and that we get the machine itself calibrated before we go into the full operation.
So that's about the size of a postage stamp. Turn it on edge so we can see how thin that is.
Yes,
too.
it is. This is
how
a
many layers do you think that is?
Oh goodness, probably about 25 or 30.
Wow.
And this is a standard kind of calibration coupon that we would use on the ground as well.
So once the printer is installed and calibrated, what happens next?
So next we'll actually start our full suite of printing engineering test coupons. You'll start seeing things like this and this, which are standard Tensile coupons that we use on the ground. Things like a Tensile coupon for testing strength of in-space printing, and the range coupon to see the tolerances that we can print on orbit.
And the variety of sizes of holes,
Little
I guess,
variety
for
of
the
sizes
gaps.
to see how small and how large we can go, yes, within a tolerance.
All right, so what do you think the team will learn from these variety of prints that you've been showing us?
The real objective of this first phase of the technology demonstration is just to verify that the process works in microgravity the same way it does on the ground. NASA and Made in Space have flown parabolic flights and tested this, but you only get the short spurts of microgravity. So being able to test this on space station and print complete parts in microgravity, as you mentioned, space station is actually the only platform where we're able to test this technology before we use it in further out exploration missions.
Now, these objects and some of these others were built right here in Marshall's additive manufacturing area in the printer that is actually on station, right?
Yes, actually, so after we finished the flight certification testing and the integration testing at Marshall, in the flight unit before it flew, we printed the full suite of samples, just like we're printing on orbit, so that we have those ground control samples. Then when the parts are returned, we'll be able to do detailed analysis to study those results and do an apples-to-apples comparison.
All right, now this is another sample you've picked up here. So it looks like the actual honest-to-goodness tools.
Yes, so I mentioned the first phase is really focused around those engineering samples that we'll be studying, but then the second phase, once we see that the process works in microgravity the same way, we'll turn its focus more toward the parts that we print and demonstrating their utilization on space station.
Well, I know NASA worked with a group of young engineers from the company Made in Space to design and test the printer. What's their role in the upcoming printer operations?
So Made in Space has been fantastic. This project is actually made possible through a small business innovation research contract where Made in Space actually designed and built the printer. with NASA involved throughout the entire process through the design and the certification to provide insight and guidance on flight certification. And we actually also performed all of the testing here at Marshall. Maiden Space is located in Silicon Valley, and they are actually today going to be doing all the commanding to the printer on orbit.
So they'll have direct control then?
Absolutely, from the ground. We try to limit astronaut time as much as possible.
Now, while this is only a technical demonstration, if you will, of 3D printing in space, why is this technology so important to future exploration?
Great question. So this is actually truly a historical moment. Since the inception of the human space program, we have been completely dependent on launching every single thing we need from Earth to space. So it's a very constrained supply and demand chain. For exploration missions, you mentioned earlier, that's just not plausible, it's not feasible. So I think we're making history by, for the first time ever, being able to make what we need when we need it in space. And even though it may sound a little like science fiction, we're actually able to email our hardware to space instead of launching it. So it's kind of cool.
That is cool. Thanks, Nikki, very much. We look
My
forward to
pleasure.
seeing some of these samples come back on
Me too.
on the return flight of SpaceX Dragon capsule in early 2015.